What is going on, guys? Hope you're doing awesome, and welcome to tutorial number 2, where we learn about the basic tensor operations, which is the fundamental building block of deep learning libraries. Alright, so let's start with what a tensor is. And from a programming perspective, essentially a tensor is a multidimensional array that has the ability to be run on the GPU. And from a more mathematical perspective, a tensor is a generalization of a scalar, vector, and matrix. So for example, a vector is a one-dimensional tensor, and a matrix is a two-dimensional tensor. So with that said, let's dive in and try to learn some of the basic operations and how we can do them in TensorFlow. We're going to start with importing TensorFlow as TF. And one thing here is that if we just run this, we're going to get these messages from TensorFlow basically saying that, I don't know, they successfully opened CUDA library and so on if you're running on the GPU. And I find this a little bit annoying. So I'm actually going to do import OS, and then you can do os.environment or environ, or whatever, however you pronounce that, TF, and then cpp min log level, and you can set this to a string equal to 2. So essentially what this will do, it will still bring us error messages, but these information will just be ignored. So if we rerun this now, we're just gonna get nothing. So anyways, let's sort of start with what we're going to go through. So I'm going to have different parts. Essentially, I'm going to start with initialization of tensors. So different ways we can actually initialize them, and then a more mathematical operations we can perform, and then indexing of a tensor, and then lastly, reshaping a tensor. So let's just start with how do we actually create a tensor in TensorFlow. So how we can do that is we can do x equals tf.constant. All right, and we can just set some value here. Let's do, I don't know, let's just do a scalar, which is just a single number. So we're just going to set 4, and then let's print that. So that's just like a tensor of a scalar value. It has no shape, although. And we can also see the D type. In this case, it's int32. And if for example, we would do 4.0, I think this would be float32. Yeah. So what we can also do is we can specify the shape. So we can do shape. Let's say we want it to be 1, 1. Then if we now rerun that, we would get something like 4 and then shape 1, 1. What you could also do is you can specify the D type. So let's say we want to have float32, you could do tf.float32, and if we run that, it would now be a float32. And I guess now it's a 1-by-1 matrix, which is just a scalar anyways, but sometimes it can be important to specify the shapes when you're doing different operations on the tensors. So let's say we want to create a matrix, so a two-dimensional tensor. We can do tf constant, and we can do a list, and then list inside that list. So we could do something like 1, 2, 3, and then comma another list, 4, 5, 6. And what this would do is it would create a 2 rows, and then each row here has 3 columns. So this would create a 2-by-3 matrix. So if we print that, we get 2-by-3. And similarly here, you can also specify the shapes and so on. Now you could also, this is, more of a manual initialization of the tensor. You could also use other initialization methods, like you could do x equals tf.once, and you could specify the shapes. So you could do something like, so a tuple as the first argument, and we could specify 3, 3. So if we print that, we would get a 3-by-3 dimensional, or rather a 3-by-3 matrix with just values of ones. And there are other operations like this. You could do x equals tf.zeros, and then, I don't know, 2-by-3. and then that would just be a 2x3 matrix of zeros. And also there are some other ones like tf.i's, and you could do, or rather I. So this is in linear algebra, you have I for the identity matrix, and if you pronounce I, that is sort of, it sounds like I, so that's how you specify a identical matrix. So that would be having ones on the diagonals and 0 everywhere else. So if we print that, we get something that looks like that. We have ones on the diagonal, and similarly here you could also specify the d type and so on. Now if you would have something from a distribution, TensorFlow also has different ways to do that. I'm just going to show you the more common ones. So if we for example want to have from a uniform distribution, we could do x equals tf.random.normal, and we can specify the shapes as the first input tuple. And let's say we just want a 3x3 matrix, and then we could do, and of course you could do more dimensions here, right? I'm just doing a matrix just for convenience. And then we could do mean equals 0, standard deviation equals 1, and so this would be from a normal distribution. And if we print that, we would get probably most values between 0 and 1. Yeah, I mean, yeah, -1 and 1. And then we can do, so if we wanted from a uniform distribution, we could do tf random.uniform. We could specify 1, 3, so a vector, and then we can specify the minimum value and the maximum value. So let's say min val equals 0 and then max val equals 1. So these would have values between 0 and 1. And it would look something like this. So those are really some, some basics initialization methods. TensorFlow has a lot more. And actually one more I want to show is that you could do something similar to the Python range function. So just tf.range. If you do tf range of 9, for example, and we print that, we would obtain a vector of 0, 1, and then up to 8. So non-inclusive the 9, exactly the same as Python. And if you want to specify more, you could do start equals, let's say 1, and then limit equals, let's say 10. And then we could also specify the delta. So delta in this case is step. I'm not really sure why they call it delta, but it's the step. So in between those values. So let's say delta equals 2. Then we would start at 1, and then the next value would be a step of 2. And then so we would get 1 and 3. So let's print that. So we get 1, 3, 5, 7, and 9. All right. So as we can see here, we now created this, and this is a vector of d type int 32. And you can specify the d type in this function, but let's say you want to convert it into a specific type. Then what you could do is you could do tf.cast, and you could send in the input vector, and then you can specify the d type. So for example, let's say we want float 64, which is quite uncommon in deep learning. All right, we need to print it as well. So normally you would have float 32 or even float 16. So float 64 is quite uncommon, but using cast, that's really a way to convert between different types. So for example, let's say we wanted float, we would do tf.float as we did, and then we would just specify sort of which bit we want. So 16, 32, 64. You could also do tf.int, and you could have 8, 16, 34, 64. And then you also have tf.bool for boolean, making it into 0 and 1. So those are just some ways to cast to different d types. All right, so let's move on to mathematical operations, and let's just create two vectors first. So let's do x equals tf constant, and then 1, 2, 3. And then let's do y equals tf constant of 9, 8, and 7. So if we would add up the columns here, we would get 10, 10, and 10. All right. And let's say we wanted to add those. We could do z equals tf.add x and y. And if we then print z, that would element-wise add each element. So this would add 1 with 9, 2 with 8, and 3 with 7. So if we run and print that, we would get just 10, 10, and 10. Now, you could also do z equals x and then plus y. That's an equivalent way of doing it. And perhaps this is the most convenient way. These are really equivalent, so it doesn't matter which one you pick. So I would probably pick the second one because that's just easier. And then if we wanted to do something like subtract them, we could do tf.subtract x and y. And similarly, you could also do z equals x minus y. And those two are equivalent as well. And let's say you wanted to, so what this would do is it would element-wise subtract. So it would subtract 1 with 9, 2 with 8, 3 with 7. And if we wanted to instead do element-wise division, so we would want to divide, let's say, 1 with 9, 2 with 8, and 3 with 7, we could then do z equals tf.divide, and then x comma y. And similarly, we could also do x and then just a division. This would also do element-wise division. And for element-wise multiplication, we could do tf.multiply x and y, but we could also do x and then just star, so x star y. And then let's say we wanted to take a dot product. So a dot product in this case would do 1 times 9 plus 2 times 8 plus 3 times 7. So it would add them up. Well, it would element-wise, so it would do a element-wise multiplication and then a summation. You can do tf.tensor. And this is a bit more of an advanced function. It can be used for more things, but in this case, we would do x and y and then specify the axis, in this case 1. And if we now print that, that would essentially do a element-wise multiplication of the elements and then a summation. So for example, if we wanted to do this sort of by hand, I guess, we would do x times y, and then we would do tf.reduce sum, and then we would specify the dimension of where we should add them. So axis equals 0, and then we could do print z. And in this way, we obtain the same result. And I'm not really sure why it's called reduce sum rather than just tf.sum. But yeah. And now let's say you want to do element-wise exponentiation. You could do z equals x, and then just similarly to Python, you would do this, and this would element-wise multiply each element, or rather element-wise exponentiate each element by 5. And then we want to print z. And then we get 132 into 143, which seems, I guess, accurate. And then I want to show you how to do matrix multiplication. So if we specify, let's say, tf random.normal, and then we do a 2x3 matrix, and then y is tf random normal, and then 3x4, we could do z equals tf.matrix multiply in matmul, and then specify just x and y. We can also do this a bit more convenient. We could do z equals x, and then I'm not really sure how you pronounce this. So x at the at symbol, I think, x at y, and then we would let's do print z on both of those. So before we run this, I just want to add 2 lines at the top here. We're gonna do physical devices. We're gonna get our GPU. And then we're going to do tf config experimental set memory growth of, I just have 1 GPU, so physical devices of 0, and then set that to true. Essentially, this will make it so that TensorFlow will not allocate all of the memory on the GPU. Sometimes you can obtain these weird errors, and if you do, then add these 2 lines. But if you don't have a problem, you shouldn't need to add those. But anyways, let's go back to printing this. So if we see now, these are equivalent, right? So you could do either matmul or just using the @ sign. All right, so let's move on to indexing of a tensor. Let's say we do something like xtf constant, and then, I don't know, just a vector with some values, 0, 1, 1, 2, 3, 1, 2, 3, something like that. Then we could do, let's do print x, and then we just do a colon like this. And what this will do is it will print all the elements, right? So this is the same as printing x, and then we get all the elements right there. But let's say we wanted to, I don't know, exclude the first element. So we wanted this part of the vector. We could do print x and then 1 colon. So this would print everything except the first, the 0 value. And then let's say we also wanted to just have these 2 right here, 1, 1. We could do, let's see, we could do print x 1, 3, and this would be non-inclusive the third index. So 0, 1, 2, 3. This would not be inclusive the value of 2 here. So we would just obtain this vector of 2 elements. Then let's also say that let's say we want all of the values. So we want all of the values, but we want to skip every other element. So for example, we want this value, we want to skip the next, and we want this value, skip the next, and so on. How we could do that is we could do : 2, and this would skip every other element. So we would obtain 0, 1, 3, 2. And then, I don't know, let's say we wanted to print this in a reverse order. We could do x and then : -1. This would print it in the reverse order. I'm just gonna comment that so it doesn't print all the time. And I guess also, let's say we just want to specify the indices. So we want, I don't know, this one and this one. So we want 0 and 2. We could do something like indices equals tf constant, and then we could specify the indices for those values. And then we could use, we could do, let's say, let's call it xInd, and then tf.gather from x, from the tensor x, we want to gather the specific indices 0 and 3. So if we print xInd, we would now obtain 0 and 2, those values that we want to extract. All right, so this is just for a vector. Let's take a more, let's take a matrix. So let's do x equals tf constant, and then let's do 1 and 2, 3 and 4, 5 and 6. So this would be a 3 by 2 dimensional matrix. And then let's say we want to get just the first row with all of the elements. How we could do that is we could do x and then 0. We could also do this by doing x comma and then all. All right. So when we add multiple dimensions of our tensor, we separate the dimensions by a comma. And similarly to how we did in a vector, we can specify the ones we want. So let's say we just want to pick out the first 2 rows. We could do x and then 0, non-inclusive the 2. So we would just 0 and 1 in this case. And then we could do comma and then all. So if we print that, we should now obtain that 2 by 2 matrix of 1 and 2 and 3 and 4. All right, so that's it for basic tensor indexing. Let's remove those print statements, and let's now move to some just basic reshaping. So let's say we have x is tf range of 9, so we would have 9 elements, and we want to reshape this. So let's do print x. Let's say we want to reshape this into a 3 by 3 matrix. Then we could do x equals tf dot reshape x, and then we specify the dimensions. So let's do 3 by 3, and let's print x now. Now we will obtain 0, 1, 0, 1, 2 as our first row, and then 3, 4, 5, 6, 7, 8 as our last row. And then let's say you want to sort of transpose this. So we would have this as our first column instead of our first row. How we could do that is we could do x equals tf.transpose x, and then we could also specify perm for permutation. And this works for multiple dimensions as well, not just for 2 dimensions as we have here. And you could specify, in this case, 1, 0, 0. So this would just swap the axis. So if we now print x, we then obtain this first row as our first column, right? And the second row is now our second row is now our second column right here. So that's it for the basics of tensor operations. Thank you so much for watching the video. And in the next video, we will start with building some basic neural networks.